sunny outside. Hope the weather is great at your place too. For those of you who do not know me, I'm Dr. Nandi. I work on statistics and math problems live in my channel. I have also solved all kinds of math problems and given lectures on all kinds of math topics and also on stat topics. So please take a look at my channel and please subscribe to my channel by hitting the red subscribe button at the bottom right corner. Okay, and if you like my videos, give me a thumbs up. That really motivates me to produce more interesting videos just for you. So we are going to solve a problem on linear regression. Linear, the word linear comes from the word line, straight line, and regression comes from the word regress, to fall back. So we will fall back on the sample data and try to fit a straight line between ordered data points, as we will do in this problem. So the following information has been collected. There are several age groups, representative age from each group, which is actually the midpoint of each group, like 25, 35, 45, 55, 65, and the corresponding average stress levels are also listed. Says construct a scatter plot of x representative age, that is your x variable. Remember, x variable is on the horizontal axis and that is the independent variable. You use the independent variable to forecast the dependent variable, which is y, and in this case y is the average stress. So you're doing ordered data points. Each of these are x and y. There is an x value 25 corresponding y value of 32. So we will first do a scatter plot. Like the name implies, scatter plot is called scatter because the points are scattered all over the x and y plane, as you will see. And we will also use TI-84 to do this scatter plot. Why? Because it's easier to see on the calculator screen. So, how to do it? So the first thing we will do with the TI-84 calculator is to clear the memories of the calculator. How do I clear the memories of the calculator? As you can see, there are information in L1 in my calculator. L1 stands for list 1. To clear the memories of the calculator, you press the second button on the top left corner. Then the plus button on the bottom right corner. So second on the top left, then plus on the bottom right. Then you press the number 4. And you will get clear all list on your calculator and you hit enter. So second plus 4, clear all list on your calculator screen, enter, done. It has cleared the memories of the calculator. Now we are going to enter the information which we see on the board here. So how do I enter the calculation, the data? Press the stat button, which is in the second row of key, stat button, and then number 1. So stat button and number 1. The cursor, the black rectangle, is sitting on top of line 1 in L1. L1 stands for list 1. It's sitting on the first line in L1, where we will enter the x values. As they say, x is the representative age. So let's enter the information. So I will type 25 on the first row and hit enter. That is the first x value. The next one is 35 and enter. Next one is 45 and enter. Then 55 and enter. Then 65 and enter. So I have entered all the x values, 25, 35, 45, 55 and 65 in L1 in the calculator. Right now my cursor is sitting on the 6th line in L1, as if it is waiting for me to enter information in the 6th line in L1. But I do not have any data on the 6th line. So I'll press the right cursor key on the top right corner of the key. If I do that, the cursor will move to the first line in L2, where I will enter the corresponding y value. So I'm entering the y value starting with the first first value 32 in the first line in L2 and then hit enter each time. So 32, enter. 35, enter. 36, enter. 34, enter. And 28, enter. That completes all my X and Y information. I've entered there. X in L1 corresponding Y in L2. I'm ready to do the scatter plot in my calculator. What will I do? I'll press the second button on the top left and then the Y equal to key on top of it. Second button and then Y equal to key on top of it. Okay. Then I press number 1. In the first line at the top left, it's plot 1 highlighted by the cursor. Next line, the cursor should be on. It should be flashing on. If it is on with the left cursor key, bring the cursor on the second line back to on and hit enter so that it's flashing on. Then you scroll down with the down arrow key to the type. Okay. The first type of chart is the scatter plot. Okay. So put your cursor on the first type of chart in type, which is the second line, and hit enter. Bottom line, it should be flashing on the first type of chart, which is a scatter plot. Now we will see below it is X list is L1, Y list is L2. Automatically the calculator assumes X list is L1, Y list is L2. Now we are ready to do the scatter plot. How do we do the scatter plot? We press the zoom button. After telling the calculator that we selected the type is the first type of chart, we'll hit the zoom button, which is the third key in the extreme top row of keys. Zoom and then 9. And you will see a scatter plot. It does not look so good because it goes up and then goes down. The points are like this. And then it goes down. So my guess will be we will fit a line like this. Some points will be above, some points will be below. Actually, it's a curve type of data. Probably we should not have done linear regression on it, but we can try our best. We can fit a line through these data points. Right now, the scatter plot looks like this, X and Y. So we have to find the equation of the least square regression line. How do we do that? Okay, so I have entered the data in L1 and L2, X data in L1, Y data in L2. Then I press I have done the scatter plot. Then I'll press the stat button again. Stat button. Highlight means move the cursor on the top line to calc. Move the cursor on the top line from edit to calc. Okay, and then press number 4 on your calculator keys. Number 4, which is linreg ax plus b. Your first line X list is L1, Y list is L2, and you go straight down to calculator. So what did I do? Stat, highlight calc, then number 4, go down to calculate and hit enter. Okay. The slope of the line, the equation of the line is given as y. There should be, the calculator does not give this cap on top of it. This means y predicted. This is the actual way to write the equation of the line. This is the equation of the least square regression line. Okay, so y hat equal to minus 0.09 x. I took the value of a from the calculator, which is minus 0.09 x plus b. Plus b is 37.05. So this is your equation of the least square regression line. Y hat equal to minus 0.09 times x plus 37.05. So the slope is the coefficient of x. Slope is minus 0.09. What is the slope? It is change in y divided by change in x. Or in other words, for every 1 unit increase in x, increase in x, y decreases. So my chart, actually the line is more like this, going down the hill. For every 1 unit increase in x, y decreases by, y decreases because of the negative slope going down the hill by 0.09. Again, slope is the coefficient of x in the equation of the straight line. Here the slope is minus 0.09. What is the definition of slope? It is the change in y divided by change in x. So if you increase x by 1 unit because you have negative slope, you are going down by that many units. It decreases by 0.09 units. Or in other words, if your representative age increases, your stress level is going down. Okay, I guess you're retiring, your job stress is going down, that's why it is going down. Interpret the meaning of the intercept. So in this equation, the intercept is 37.05. It is the value of y when x is equal to 0. What is the representative age? 0. In this case, the intercept has no meaning. Intercept has no meaning because all the values of x are positive. All the values of the ages are positive. Had there been positive and negative ages, which is not possible, then there would be a value of the intercept. All the values of x are positive. So again, we need to have positive and negative values of x for the intercept to have some meaning. But in our case, all the values of x are positive, therefore the intercept has no practical meaning. Then they say, what is the average stress predicted for a representative age of 35? That means we will use the least square regression line equation, which is y equal to minus 0.09 x plus 37.05. For x, we will plug in, for x, use x equal to 35 in the equation. So our y hat will be minus 0.09 times x. X is 35 times 35 plus 37.05. And y hat, this is to be read as y hat, which is predicted y. Predicted y. Okay. So we will multiply. How do I get this negative sign? It is the negative sign next to the enter in that bottom right. That is the negative we are going to use. Negative 0.09 times the representative age is 35, multiply by 35, and then add 37.05 to it. So we are using basically the least square regression line minus slope of 0.09 times the representative age has been x equal to 35, plus the intercept, and the answer is 33.9. 33.9. Now at x equal to 35, the data, original data, y actual, the actual data is, we get it from the table, is 35. So what is the residual? Residual is y actual minus y predicted, which we go by hat. So y actual is 35 and y predicted is 33.9. So y actual is the value that we have actual in the data, 35. Y predicted is when we took x equal to 35 and plugged it in, we got 33.9 as the y predicted. So the difference between the actual value of y in the table minus the predicted value of 33.9 is the residual. So 35 minus 33.9 is 1.1, is equal to 1.1. That's your residual. Okay. Then they ask for what are the values of r and r square. R is correlation coefficient. Closer it is to 1, better is the correlation. R is the correlation coefficient. And I do not see any R. If you do stat, calc, and number 4, X list is L1, Y list is L2, go down to calculate, you will not see any R. Okay, so we have to bring R. How do I do it? So please work with me. Do second and 0, and you will see all this A stuff open up. So we scroll down with the down arrow key till we go to diagnostic on. And this you only do once in the calculator, unless and until you switch it off or something. So C, A, B, C, our goal is to reach to diagnostic. The first one will be diagnostic off, so keep scrolling down with the down arrow key till you come to D in David. The first entry in D is day of week. Your goal is to go on diagnostic on. The first one is diagnostic, diagnostic off. You are not interested in this one, diagnostic off. So you are interested is diagnostic on. Your cursor should be aligned with diagnostic on and hit enter. And again you see diagnostic on your calculator screen, hit enter. And it says done. From now onwards, you will see R and R square. So stat, highlight calc on the top line, then number 4, linreg ax plus b, go down to calculate and hit enter. And your R value is negative 0.45. Okay, what does it mean? Negative, weak, negative correlation. Correlation means together relation. Okay, weak negative correlation. Okay, and then you also get the R square value. This is, both of them should be close to 1 to get a good correlation, but our R square value is 0.203 say, and we only multiply the R square value, which is coefficient of determination, by 100%. So decimal shifts 2 places to the right, it becomes 20.3% of the variation in Y can be explained by the least square regression line by the least linear regression model. Is that good? No. Ideally, we should look for greater than 70%. And I explained to you it's not good because there is a curve in the data. Linear regression line. So, let me recapitulate what I did. So first, I was asked to make a scatter plot. So I entered the X data in L1 of TI-84, Y data, corresponding Y data in L2 of your calculator. Then I did second button on the top left and Y equal to key on top of it. Then number one is plot one, it should be on, and type should be the first type of chart. Bring the cursor on the first type of chart, which is the scatter plot, and hit enter. And then I saw this kind of X and Y scatter plot. This is called a scatter plot because the points are scattered on the XY plane. And it is not a linear relationship, kind of going down the hill, but it is a curve pattern. So ideally we should not fit a line, but in this case we have been asked to fit a line. So the line, you have to calculate what is the equation of the least square regression line. For that you do stat calc 4 and then you go down to calculate and hit enter, and this is the equation. The calculator does not give the y with a symbol on the top, it is a hat on the top. What is the y hat? It is the predicted y, and it's given by this equation. The coefficient of x is the number in front of x, in this case is negative 0.09. That is the slope. What does the slope mean? The slope means for every 1 unit increase in x, y is decreasing by 0.09. Why it is decreasing? Because it's going down the hill. As you can see from the data, as people's age increase, their stress level goes down. This is very practical because as people get older and older, they retire from their stressful job, and therefore their stress level also goes down. Makes sense? Okay. So the intercept is the number after the plus sign. In this case, it is 37.05. Does it have any practical meaning? No, in this case, because we only have positive values of x in the data. X is the representative age. If we had both negative and positive values of x, then the intercept would have meant the value of y when x equal to 0. In this case, because we have only positive values of x, the intercept has no meaning. Okay. Then they give us an x value and want us to use the equation to predict or forecast the value of the average stress. Our x was given as 35, so we multiply the slope with 35 and then add 37.05 to it. It comes out the predicted value of stress at x equal to 35 is 33.9. Then they ask us to calculate the residual. Residual is the error. It is the y actual minus y predicted. For 35x, y actual is 35. What is the predicted value? 33.9. So the difference is 1.1 is the residual, sometimes called the error. Again, residual is the difference between what is the actual value of y minus the predicted value of y. Okay, in this case it's 35 minus 33.9 is 1.1. What does it mean? It means the actual point is located above the line, what is predicted by the line. Okay, and then it asks what are the values of r and r square. So to get r and r square, you have to do it only once. Okay, you do second and 0, and then you will see the arrows, cursor on the A as in apps, A, alpha. A is the first letter in the alphabet. You keep scrolling down till you go to D as in David, and your goal is to align the cursor or the arrow on the left to diagonal stick on. You do it only once, okay, diagonal stick on, and hit enter. Okay, and then it will say diagnostic on the calculator screen. Again hit enter and it will say done. Now if you do stat calc 4 and then go down to calculate, it will give you not only the least square regression line, it will give you the value of r and r square. What is r? R is called a correlation coefficient. In this case, the correlation coefficient is minus 0.5. So r is a correlation coefficient. It shows the strength of the relation between x and y. It should be ideally close to 1. In this case, 1 or minus 1. Minus 1 when it goes down the hill. It came out as minus 0.45. It's not very strong. So weak negative relationship. Why weak? Because it's not close to 1. And why the negative meaning? As x increases, y decreases. As x increases, y decreases. Going down the hill. Hence r is negative. Weak negative correlation. When it is strong, strong is above 0.7. And then we also get r square. In this case, again r square value, the lowest value is 0, highest value is 1. Ideally, we would want r square to be close to 1. In this case, it is 0.203. We multiply only r square by 100%. Shift the decimal 2 places to the right, r square becomes 20.3% in this case. What does it mean? Okay, it means 20.3% of the variation in y can be explained by the linear regression model. Is this good? No, it is not good. Why it is not good? The main reason, it is a curve relationship. And we have a fitted a line which goes down the hill. So we have missed a lot of points. Okay, that's why the correlation coefficient came out negative down the hill, and the coefficient of determination, which is r square. Okay, r square is called coefficient of determination. Came out only 0.203, multiplied by 100, 20.3% of the variation can be explained by the linear regression model. So I'm going to stop here. But if you have any question, please do not hesitate to shoot me a question and I'll respond to each and one of your questions. And if you like this video, please give me a thumbs up. It motivates me to produce more interesting videos just for you. And I appreciate the fact that you took time to watch my video. And please, if you like this video, share with your friends, and please subscribe to my channel by hitting the red subscribe button. And please do not forget to watch me tomorrow when I'll be back with another interesting video. Thanks for watching. Take care. Have a nice day. Take care. See you.